Hello, we're presenting to you from a COVID-19 world where we're limited in how we can share space with people. What we want to talk to you about today is a way to connect, to put another virtual person in your space. Here's David Attenborough. The one on the right is real, the one on the left, and the rest of the scene is captured with volumetric video, interactive 3D video. If you were wearing those goggles, Attenborough would be in the room with you. And here's the massive studio where they made the volumetric capture. David Attenborough is one of the greatest presenters of the natural world, but in this setup, he's totally removed from the outside world. The question we've focused on with this project is how do we do volumetric capture in the real world? We're focused on taking 3D capture out of the studio and making it portable. This is our studio in a lunchbox. Here's the real-world setup, light and unobtrusive, and the resulting demo footage. What this does that's different is let the reader change their point of view and feel like they're on the court, not just watching remotely from the sidelines. This is our team from the Newmark Graduate School of Journalism at CUNY, along with volume creator Ben Kreimer. Our team is bringing a variety of journalistic experience to expand on a very technical project. This spring, we worked on this project with mentors at the New York Times as part of the Spatial News Challenge with the New York City Media Lab. We want to make it more feasible for journalists to capture 3D video in the field. These are the primary tools: the Volum Box depth camera, the volume workflow, which brings all of the 3D elements together in a photogrammetry scene. And in this case, we're delivering the story via augmented reality, and we can output to virtual reality or desktop as well. We've also developed documentation to make it easier for people to get started. 3D video is truly journalistic because it captures the event as it happened in real life. We're excited to let readers interact with high-fidelity scenes in motion, not just seeing an image, but sharing space with a character. Right now, there's no off-the-shelf system for capturing volumetric video in the field. Volumetric cameras don't work like DSLRs. Recording 3D video requires a computer and a depth camera plugged into a power source. It's not practical to bring this setup into the field. Here's the solution we're using. The Volum Box camera is a DIY setup that fits the camera and computer into a portable case. The other challenge is that there's no easy software pipeline. The current state of the technology isn't simple. To make the volume pipeline work, we're stringing together a lot of software to produce a 3D scene. To work through those challenges, we wanted to test and refine the pipeline with a real subject. We worked with Mark Mitten, a professional magician who uses magic to better understand how we see the world. These are the 6 things we need to do: capture, photogrammetry, footage conversion, sync the audio and video, publish, and make it viewable. And our setup for the capture. The Volum Box. The camera captures both image and depth information for every frame. We're making the process simpler, but it's pretty complex now, including a few steps in the command line, and extracting each frame of the video. We also capture the stage by photographing the real room and using those still images to stitch together a 3D photogrammetry model. This part doesn't move, so we don't need video. Everything comes together here in Unity, where we precisely align the volumetric video of the magician with the 3D photogrammetry model to accurately reproduce the scene we captured. We've put together a guide that will open this format up to more people, and so storytellers can create immersive pieces more efficiently. The guide includes step-by-step instructions and videos for the workflow as it stands today. We want to make it possible for journalists to tell stories like these: a health and wellness story about yoga, a story about dance and digital culture, or a story about science. These are the improvements we still want to see. We hope we can get the technology to catch up with our ambitions. We're excited to be at this virtual demo day and look forward to talking with you.